Welcome. In this lecture, I'm going to talk about the default types. Let's check it out now. Let's take a look at an example. Here I declare a constant with a type. So the type of the mean constant is int32. Now let me declare a variable using this constant. Here I'm using an expression. 5 is a typeless integer literal, and mean is a typed constant with int32 type. Okay, here is a quick question. What is the type of the max variable? Please pause the video and think about it. Alright, here is the answer. It is int32. Why? Let me explain. Here, I'm declaring a variable, right? And every variable needs a type. So Go needs to find a type for this variable. But how? There is a typed value in this expression. Yes, it's the mean. It has a type. Its type is int32. Another problem is, to make this expression work, Go needs to convert the typeless integer 5 to the type of the mean. So Go decides to convert the 5 to the int32 like this. And in the end, max variable's type becomes int32. So in summary, when a type is needed, Go will convert the typeless constant to a type. And it does so automatically to make the expressions work. Here it converts it to int32 because that's the only way to make 5 plus mean expression to work. But what happens if it couldn't find a type? I mean, what if there wasn't a mean there? What if there wasn't a type information anywhere? To answer that, let's take a look at another example. Here is the same constant again, but without a type this time. As you can see, it's a typeless constant. And there is also the same variable declaration with the same expression, right? As you can see, there isn't any type information here. 5 is a typeless integer literal, and mean constant is also typeless. So how Go will find the type of the max variable? As you know, a variable always needs a type. It needs to find it somehow, but how? Please pause the video and think about this a little. Okay, here's the answer. Go converts the 5 and the mean constant to int. But why does it do so? It's because the default type of integer values is int. So when Go can't find any type information from the surrounding values, it gets the type from the default types. Every basic literal has a default type. Here, the mean constant is equals to 1. So it's actually like an integer literal. So its default type is int. That's why Go converts it to int. And 5 is an integer literal, obviously. So Go also converts it to its default type, which is int. Now let's take a look at the default types of all the basic literals in Go. Let's short declare a variable using an integer constant like this. Can you guess the type of the I variable? I'm not gonna ask you that. Sure, you know that its type is int. As I told you before, the basic literals are untyped constants. So how Go finds out the type of the I variable? Did you ever think about that? It extracts the type of the integer literal, right? But I told you that an integer literal doesn't have a type. It's typeless. So how Go finds its type? Think about this for a second. Okay. It's because, as I said before, an untyped constant like an integer literal has a default type. So when a type is needed and the type is not clear from the context, Go converts the untyped constant to its default type. Here, the type of the I variable isn't clear, but it should have a type, since it's a variable. And a variable always have to have a type, right? So Go declares the type of the I variable by looking at its initial value. And there is an integer literal, 42. It's typeless. So Go thinks that, okay, there isn't a type information, so I should better assume that the type of this integer literal is an int, because an integer literal's default type is int. So in the end, I variable's type becomes an int. Okay, let's take a look at another example. Now let's short declare another variable using a typeless float literal this time. So what's gonna be the type of the f variable now? It is float 64, right? It's because a float literal's default type is float 64. Okay, let's short declare one more variable, this time with a typeless bool constant. the type of the B variable becomes a bool. It's because true or false values default type is bool. And one more. Let's short declare a variable with a string literal. The type of the S variable becomes a string, since a string literal's default type is a string. And lastly, let's short declare a variable using a rune literal. So the type of the R variable becomes rune. It's because a rune literal's default type is rune. Alright, that's all for the default types. Now let me show you an example. Now I'm gonna declare a variable with an initial expression. Let me ask you a question. What is the type of this expression and the variable? Please pause the video and think about it. Okay, let's check it out. The answer is float64. It's because, as I told you, when an integer value and a float value is used in the same expression, the result becomes a float. Actually, this was the first step. The result of this expression is still a typeless float value. Why? It's because 42 and 3.14 are typeless values. So the result of the expression also becomes a typeless value. And here is the second step. Go needs to convert the typeless float value to its default type. So Go converts the expression to float value's default type, which is float64. This happens because the I variable needs a type. Always remember, the conversion only happens when a type is needed. Go doesn't convert any typeless value without a reason. Now let's declare another variable. Here I'm using a bool constant with a string literal in the same expression. They both are typeless values, right? So here's another question. What will be the type of the F variable here? Actually, nothing. It's because untypedness doesn't mean that you can mix incompatible values together. So as in here, you can't use an untyped bool value and an untyped string literal in the same expression. They are incompatible values. They cannot be converted between each other. You can't convert a string literal to a bool value or a bool value to a string literal, right? So that's why they are incompatible values. Alright, this lecture ends here. Thank you for watching. See you in the next lecture.